Hello, Windows Analysis. We explore the Windows universe, performance, hidden settings, history, hacks, and updates. If you like understanding your system, stay tuned. Today, we're opening a door to a whole other universe that lives right inside your computer. Yeah, we're talking about running the full raw power of Linux seamlessly on your Windows desktop. So let's just get right to it. Have you ever wished you could get a full-fledged, powerful Linux environment running inside Windows, but without all the usual headaches? Well, the answer today is a huge, resounding yes. And we're going to see exactly how this technology is literally changing the game for developers, sysadmins, and, anyone who's just curious. Okay, to really get how big a deal this is, we've got to take a quick look back. For years, trying to use native Linux tools on Windows was, well, it was a nightmare. Your options were basically a risky dual boot setup where you just prayed you didn't nuke your entire system, or you'd fire up these slow, heavy virtual machines that would just devour all your RAM and CPU. What used to mean rebooting your whole PC is now instant. Two totally separate worlds are now one. This isn't just some small improvement, it is a full-on revolution.
And the hero of this story, this massive shift, is the Windows Subsystem for Linux, or WSL. But specifically, we're talking about version 2, WSL 2. And make no mistake, this wasn't just some minor update. Oh no, this was a complete reinvention of how Linux and Windows can not only live together, but actually work together on the same machine.
So what is WSL2 really? Well, it's way more than just a simple compatibility layer. It runs a real, honest-to-goodness Linux kernel inside this super lightweight, highly optimized virtual machine. And this is the key part. We are not emulating anything here. We are running genuine Linux with all of its full, unadulterated power. Now, this is where it gets really interesting. WSL1 was clever, right? It acted like a translator, turning Linux system calls into Windows calls on the fly. And it kind of worked, but it had its limits. WSL2, by putting a real Linux kernel on top of Hyper-V, is playing a whole different ballgame. We're talking 100% system call compatibility. This is what lets us run absolute powerhouses like Docker and Kubernetes natively, something that was just a dream with WSL1. And that file system point? Oh yeah, we'll get back to that because there's a crucial trick you need to know. So the bottom line here is crystal clear. For any serious modern work, I'm talking development, machine learning, system administration, you name it, WSL2 is no longer just a neat option. It's the standard. That total compatibility you get from having a real kernel, it's just something you can't compromise on anymore.
All right, now for the fun part. What can you actually do with all this power? Let's talk about the superpowers that this thing unlocks.
Firing up WSL2 is basically like giving your Windows machine a superhero upgrade. All of a sudden, it becomes this developer's Swiss Army knife, ready to handle just about any technical task you can throw at it.
I mean, the possibilities are just huge. You can spin up a complete web dev environment with something like Node.js in the time it takes to make a coffee. You can train complex AI models, actually using your GPU's power with CUDA. Or hey, why not unleash the entire massive arsenal of Linux cybersecurity tools? You can manage your whole cloud infrastructure right from a single terminal. It's wild. And this is where it starts to feel like actual magic. Thanks to a feature called WSLG, we're not stuck in the command line anymore. We can now launch graphical Linux apps, like GIMP or a Linux-based code editor, whatever. And bam, it just appears on your Windows desktop like any other normal app. No more fighting with X servers or weird configurations. You just open it and it works.
And this chart just says it all. To give you an idea of the insane difference GPU acceleration makes, in tests, graphics performance with WSL2's virtual GPU can hit 350 frames per second. Without it, using old-school software rendering, it just crawls along at maybe 4 FPS. It's not a difference, it's a literal abyss. This is what makes heavy-duty data science and machine learning work truly possible on Windows now.
Okay, so we know what WSL2 is, we know what it can do, but to really master it, you need to know a few secrets. So let's dive into the pro tips that will help you squeeze out every last drop of performance and avoid those common frustrations.
Okay, listen up, because this is probably the single most important tip you're ever going to get about WSL. Ever wonder why sometimes compiling a project or just listing files feels like it's moving at a snail's pace? The answer is simple, but it is fundamental. It's all about where your files live. Here is the golden rule. For lightning-fast speeds, your project files must live inside the Linux file system, so in a path like /home/your user.
If you try to work on them from your Windows C drive, WSL2 has to use this slow network protocol to talk to them, and that just kills performance. By default, WSL2 can be a little hungry with your RAM. It likes to reserve a big chunk. But you can put it on a diet. It's super easy. You just create a simple text file, name it .wslconfig, and put it in your main Windows user folder. Inside that file, you can set limits, like memory 8 GB, so it never goes past that. After you save it, just pop open PowerShell, type WSL-shutdown, and the next time it starts, your new sane limits are in place. Easy.
Now, for a really important warning. When you enable WSL2, you're also turning on Microsoft's hypervisor, which is called Hyper-V. And as the quote says, Hyper-V puts itself ahead of everything. It takes control of the hardware at a very low level. So what does that mean for you? It means that other virtualization programs like VirtualBox or VMware can suddenly start to perform terribly because they can't get that direct hardware access anymore. It's a huge thing to keep in mind.
So, as we wrap up, it's so important to understand that WSL2 isn't just some isolated terminal window you open once in a while. It has become a deeply integrated, absolutely key part of the modern workflow for anyone developing on Windows today. And this is where it all just clicks into place. The integration with the tools we use every single day is seamless. With Visual Studio Code, your editor connects directly to a server running inside Linux, so you get a totally native experience. Docker Desktop now uses WSL2 as its default engine, which makes performance and compatibility just spectacular. And when you get into things like dev containers, you can create and share entire isolated development setups with just one click. It's a marvel. And all of this really leads us to this final big question. With this kind of power, this level of deep integration where the lines between Windows and Linux are practically vanishing before our eyes, are we actually seeing the future of how development will be done in the entire Microsoft platform? It's definitely something to think about, and that's it for today's analysis. If you liked it, subscribe, leave a like, and a comment. Enjoy tinkering, and see you in the next Windows analysis video.